Hello everyone, welcome to Learn Overflow. In this video, we will look into today's LeetCode problem, that is the binary tree with factors. This is a medium level problem and we'll understand how we can solve a question like this, how we can think of solving a question like this, how we should go ahead and step by step to find a solution of this kind of questions. Okay, so that will be our main target. So before moving on, make sure to subscribe to this channel for regular late code videos like this. Also, make sure to check out the description. If you have, you will find all the related details to this question in the description as well. So make sure to check that out also. So let's start with this video. Uh, the question says, like, given an array of unique integers ARR. So ARR is an input that is given to us. There's a parameter given to us. Fine. So it says like it has unique integers. So there isn't any repetition of numbers. Okay, fine. And where each integer is strictly greater than one. Okay, so it mentioned that this is strictly greater than one. So you cannot find one or less than one. You should always find numbers that are greater than one. Fine. Now, what we need to do, we make a binary tree using these integers. So we will make a binary tree. What is a binary tree? There will be a node and there will be at most two children out of it. Fine. So that's a binary tree. And that's the go through the definition if you don't know much about binary tree. And it says like we make a binary tree using this integers and each number may be used for any number of times. Okay, so we can use each of the integers that is given in our array to be like any number of times. Okay, and also it mentions that uh, each non-leaf node's value should be equal to the product of the value of its children. So say there are two children, okay, and there is a non-leaf node, some kind of root is there, a non-leaf node is there. So if it has two children, then each non-leaf node, that is this node, should be the product of its two children. Fine. The product of the numbers that are there, so it should be a product of the two children. Okay, so that's the question given to us. So this is a tricky line and we need to actually make sure we follow this line. Once we follow this line, the question is done. The question ends at that question. So we will understand how what I mean by saying this. I will explain you one by one into that. Okay, fine. The question further says return the number of binary tree we can make. So we are not interested to make a binary tree. Rather, we need to count like how many binary trees we can make out of it. So that's the whole idea in this. Okay. So and at last, like it says, an answer may be long, so we should return a module of 10 to the power 9 plus 7. So that's a common thing. So now let's understand this example over here. Fine. In this example, it is given like the array is given of values 2 and a value 4. Fine. So there are two elements given to us. Fine. Now it says that the output is 3. So if it says the output is 3, therefore that means that we can make 3 binary trees out of it. And what can be those 3 binary trees? See, one of those is like the element itself. So make sure to count that element itself. So that's the normal count, that the element itself is a binary tree. Okay, so the element itself, fine. And the third one is 422. That means root is 4 and the leaf nodes are 2 and the leaf node is 2. So that's 422. So 2 into 2 is 4 and that's the root node. Okay, so that's what this particular statement says to us, that each non-leaf node, that is this leaf node 4, non-leaf node 4, non-leaf node value should be equal to the product of the value of his two children. Value of the children is 2 into 2. And also it mentioned that we can use any number of times. So 2 was given once in our array and we used this twice to find the value in our like to make a binary tree out of it. See, now the thing we need to think of is like, look carefully. What we exactly need to think is like, we are given 2 and 4. Is it anywhere mentioned that they will give 2 and 4 and not 4 and 2? Uh, is it mentioned? No. So they didn't mention that the array is completely sorted for us. So how does it actually matter? Let's look into like whether this condition matters to us or not. Okay. So they simply given us two examples where the examples are already sorted, but is it actually matters or not? Let's look into that thing. Now, first of all, in our count, what's the count we need to do? We need to do that the how many elements are there, that the each of the elements in our array is itself a like each of the elements is itself value itself, is itself one tree in itself, right? So how many values are there in our array is already added to the count. Fine. So that's the minimum count. Now, further, what we need to do, if we are looking for a number, say a of I in this, if we are saying 4, fine. If we are looking for a number a of I, and if that number has a divisor a of j being some other number, fine. If that number is finding a divisor a of j, say a of j is 2, fine. If both this number are there in the what I mean is, if a number is a of I is there in our particular array, and its divisor is also there in the array, okay, then we need to look for if its dividend is there or not. What it means, that a of I by a of j is there in the array or not. If that is there, like if particular number a of I and the number and the divisor a of j is there, then a of I by a of j is also there. That means, so 4 by 2 is what? Is 2. 2 is there in the array, right? So if it's also there, that means we can make a tree out of it. What I mean exactly is, see, we are required to find the product of its value of the children. Fine. A root is there when it has two children, at most two children, but it has two children, and we need to find the product of the values of the two children. Fine. How can we go ahead with that? We cannot think directly. We can find that a number a of I is there, that is the root we are considering, and its dividend is there, that is one of the subtree value, fine. Its dividend is there in the array. Then we need to look for whether a of I, that is the root divided by a subtree, uh, is it divisible by is it divisible, like it's obviously divisible because the divisor is there, so it's divisible, and whether the dividend is there in our particular array or not. So if that is there, then we got our right subtree as well, fine. So it's basically we are supposed to product this two and come up to a value that is the root, but we are looking in a different order, that if the root is there, if one of the subtree value leaf node is there, and then we are trying to find out what if we divide the root with one of the leaf node and find whether the other leaf node is also there in our array or not. If all the three are there, then we found another uh, tree for us, fine. So uh, we can actually find the another tree. Like how can we do that? We need to find like the total number of dividends that are possible, and total number of ai, that the root divided by like root divided by the dividends, how many are that, root divided by the divisor, how many are those are possible. So we should multiply them and we find some more values out of this, fine. And then we should just count the total number. Initial numbers were how many elements are there in the array, and then we should keep on finding the divisor and the element, how many of them, and multiply them to just find out how many like dividends can be possible, and count them. So that's the more or less the idea, to find the idea. See what exactly. Let's take the example I was just discussing on the conceptual parts. Let's take an example. Say you got 10. Fine, you got a root element that is 10. You think that this is one of your root element. Okay, you don't know much about it. Then a of I is your 10. Fine, you find another element that is a of j, that is 5. Fine, you find 5. Okay, now your task is to find out whether 10 divided by 5 is there in our array or not. What's 10 divided by 5? 10 divided by 5 is 2. Is 2 an element there in your array? Yes, there's 2 in your array. So once 10 divided by 5 is there in your array, then see that becomes a element in your like particular element in your uh, uh, exact, like the count increases. But look further, what if the other way around, like this case you need to count this case as well. So we counted 10 divided by 5 is 2, that is this one. We need to also count the 10 divided by 2 is 5, that is also present. See, the count is also considered in our example. Fine. So initially, what we did, we checked for all the singular elements, because all the singular elements are itself a tree. Now, the next thing we did is like we took a larger element. So once in those cases, what can we do? We can go ahead with a sorted array, because if it's a sorted array, then we know that the smaller elements are at the beginning. Okay, if we need to find that 10 divided by 5 is 2, whether 2 is there in our array or not, we don't need to search the whole array. Rather, we can directly find it out in from the beginning. If we start finding from the beginning, we can directly find it out, right? So the search elements like this, searching won't go for long. Fine. So that's the more or less the idea. Fine. I hope this is understandable, that our target is to find the root, like initially count, make a count of all those, and then find a root. So how we can go ahead and do this? So for doing this, we will use an hash map of like the integers, this integers for us, fine, and the particular mapping it to some long variables to get the count of that particular indexes, fine. What this hash map will do, it will hash map will initially put all the ai means all the elements of this array, fine. It will simply put all the elements of the array in our hash map. So with that count, we know that okay, we at least counted our all the elements. Further, we'll do, we'll simply go ahead and check for the devices, like whether our like the whether eh, each of the element can be divided or not. If it's not divided, we'll go ahead with the count 0. If we can divide it, we can go ahead with the count of 1. Like once we find an element for like say with for 10 there's initially one value. For 10 there will be two more values, that is two more values can be there. So for 10 there will be a value of 3, so we'll count it as a long time variable, because it can go ahead with a much larger value. For the smaller value, so it's okay. But see, array length can go up to 1,000 elements, and array of I can go up to 10 to the power 9. So in that case, we'll go ahead with a long time variable, so to find out like whether it is possible or not. Okay, so that's the idea. So let's quickly go ahead and write this code. I'll again explain it to you why and how we did what steps. Okay, I'll explain you step by step. So let me quickly write this code and help you with it. So let's understand what we did in this question, like what actually we did in our solution over here. Fine. So the first of all, we took this variable answer. That's the final return answer. So initially it's like 0. Fine. You see L at the last. So L at the last denotes that it's a long time. Okay. Further, we just sorted this. Why sorted this? We'll see at this position, at this level, how sorting this array helps us. We'll see over here. Fine. Next thing, we just took an hash map. Hash map having the integer and a long time variable storing the count actually. Fine. Next, we go ahead with our whole array of ARR. Fine. Now in this array, we in this area, what we go do, we simply put all the each of the singular elements first. like each of the elements in our DP, like in our hash map. Fine. In our hash map, we just put them one by one with like value one L. One and then L is just long, so value one. Fine. So what it does for us, if we just initially make a count of all the singular elements, like all the singular elements as a tree. Fine. The next thing what we do, we check for we go ahead with values from 0 till less than I. Since it is sorted, because since we sorted this in this case, so how this helps for us, say we are at value 10, we know it divisor and dividend all with lie below it, so we can simply go ahead with 0 till I. Okay, so once you go ahead with this, first we encounter 2, so we find out 5 as its divisor. Okay, and then we initially encounter 5, then we find out 2 as its divisor. Okay, so that's the whole idea. So the sorting helps us in that manner. Else say there is a value like 10,000 that's lies before 10, like in a given array. If a value like a bigger value like 10,000 lies before 10, so we will try to divide that and end up having some errors or all. So it's better to just sort it. So that's the idea behind sorting this. Fine. Now in the next step we simply start from less than I, like 0 till less than I for all the values less than I, and we check if array of I is this value initially. Okay, and is divisible by, like if we divide array of I with array of j, if whether its remainder is 0 or not. So if 10 divided by 4, its remainder won't be 0, but if 10 divided by 2, its remainder will be 0, and for 5 its remainder will be 0. So once we find that this is divisible, then our target is to find whether the other value, like after dividing what value we are coming across, whether that value is there in our array or not. How we are going out with that, we are, see what we're doing, we are taking dp dot put array of I. So array of I is current value is 10. Remember, the array of I is initially 1L. We just counted 10 as 1 itself. Fine. Further, what we did, array of I, we took the, we are trying to change the value related to array of I. Let me just uh, take it, like the initial value of 10 is like 1L over here, so we just that's the initial value over here. Now we are updating this value, so we are dp put error 5, and what's the value we are updating is the value coming from here. Okay, so let's read the statement step by step, and let's try to understand what the statement does. The statement first get dp.get error of I, so we just get the initial value of error of I, that is 1, so we just get the value initially. Fine. With that we add something, we add a multiplication of two values. Fine. What is that? dp.get error of j. dp.get error of j is what, say error of j is currently pointing at 2, so 2 initially was 1, that is the element itself, because we don't have any other divisors or dividends of it in the array. So 2 is initially 1. Fine. So if you get AR of j, we found that this is 1. So we just try to sum of 1 multiplied by, fine, multiplied by dp dot get or default AR of I by AR of j. AR of I by AR of j is 10 by 2. 10 by 2 is what? 5. Why we are going with get or default? If that 5 is not there in our particular array, okay, in that case we will go with the default value of 0, so we'll multiply 1 with 0 if 5 was not there. But since 5 was there, what's the default value of 5, or what the value of 5? 5 is actually storing 1, so 1 into 1, so it's coming across is like 1 to 1, so 1 plus 1 is 2, so the value gets updated to 2. Fine. In the next step, when uh, j becomes 5, or when j points at 5, how we go ahead, we just do like the same thing here, we are updating this 2, like the period put error of I is getting updated, and in that we are just like first getting the value itself. So 2 plus we're summing it to it, and then a product of two values. So dp dot get AR of j. What was AR of j? AR of j was 5 in this case, so 1 multiplied by dp dot get dot diff of I by j. So 10 by 2 5 is 2. If 2 was not there in our array, so in that case it would have thrown as a 0. uh, and if since 2 was there in our array, it will simply give us an 1. So 1 into 1. So what the value is coming across over here? So it's, you can see it's like 3 is the count. So see, for 10 there are like 3 values we can come across. So those are the 3 values getting counted. Okay, as 10 as the root, we get 3 values. Okay, the similar way it goes for the 4. Like 4 has 2 values, so 4 once itself, and 4 over here. Okay, 4 has 2 values, and for 2 and 5, for 2 and 5 there are 1 value each. Fine. For now, after that we are simply adding, since this value, this current ith position value is getting over, so we are simply adding all the ith position value to our final answer. All the ith position added to a final answer with this mod with it. Fine. And returning our answer to it. So once we're returning this, what we're getting? We are getting simply the values. Now we are getting the count as a 7. So that's the idea behind the whole question. You can, if you think, you can actually go ahead with like solving or reducing the time complexity to some extent. The time complexity more or less lies in a order of n square. So thank you all for watching this video. I hope I can make you understand how this question works for you, and how exactly you can go ahead with solving a question like this. So if you have any doubts with this, so make sure to comment it down in the comment section as well. I'll be happy to help you out. Also, like this video if you think it was worth it for you to learn how to solve this kind of question, and subscribe to this channel Learn Overflow for regular LeetCode videos like this. Thank you all for watching this video.